Good afternoon and good evening, everybody. My name is Dan Quigley, November 7 Hotel, Quebec from Flex Radio Systems. And I'm here to talk about integrating your station and doing a little bit of automation. Um, so uh, just, starting at the beginning, what is station integration? Well, it's really a form of systems integration, which, if you follow the classical definition, is the composition of a capability by assembling elements in a way that allows them to work together to achieve an intended purpose. Well, um, basically, it's just hooking a bunch of stuff up and making sure that it works. But to do that, you really need to follow a process, and it's a design build process, and you're probably familiar with some of those processes. I'm going to introduce one to you here, but it's basically designed to help you follow the documented manufacturer and amateur radio best practices. Another thing to remember about integrating your system is we're a community of operators, and Flex operates and maintains a community for owners of our products and other products at community.flexradio.com. And you'll find on that community a group of experts and Elmers that are willing to answer any question and help you get over any hurdle. So again, don't feel like you have to do it alone. Ask for assistance. Take advantage of the community that we maintain. Okay, so again, going back to talk about how the station integration is really a life cycle or process. So let's describe what that process is. First is analyzing the requirements. Now, this for a lot of people is the most fun part of the whole process, because this is really where you get to dream and you get to figure out how long of a piece of coax do you need, what kind of coax, what kind of attenuation can you absorb in that coax length, what kind of amplifier you're going to use. All of those questions really kind of roll out requirements, and those requirements should be based not only on the physical installation of your station, but what your personal preferences are. So, requirements analysis is always the first step of a product. Now, the next step is designing it, and designing it is a step that you should never miss, because this is where you take your requirements and you map them against the like the inputs and outputs of a transceiver, for example, or how are you going to achieve something if you have to build an interface cable. So this is where you actually design not only the physical connections or interconnections or even the installation of something, but the software side of it. It's a step that is required. Another great piece of advice is that you really want to add to a system in layers. Even if you design a much bigger system, start with a foundation, build the foundation first, and then build incrementally. And then as you go, document this, right? So, one of the tools that I use to put this presentation together is something called draw.io. I use it for many of the drawings that you're going to see in this presentation. That one document, that one drawing, it could be really the only documentation that you need. And we think so much of this particular part of the process and life cycle that we have a template library that has, the ins and outs on our Flex 6000 series receivers. And if you send a help desk request to us after the show at any time, we'll be happy to supply that to you. The next step then is testing and evaluating. So, once you build a piece of your system, again, test as you go. Don't build the entire thing and then perform one massive test. It usually works out much better for you if you test and you evaluate the performance as you go. And then you're on to sort of one of the last steps, which is maintain and operate it. Now, maintenance is a step that almost a lot of people leave out, right? Maintenance could be just opening it up and blowing the dust out of something, or moving it and blowing the dust from behind it. Maintenance also should include things like checking your antenna lightning arresters and making sure that the protective elements inside of those are operational. Inspect the coax connections, make sure that they're not have gone bad or have weakened because of mechanical or some other stress. Maintenance is a part of the operation of it. I've talked to a lot of customers in my job at Flex Radio, and many of the problems that we run across helping customers through issues that just seem to crop up can relate back to poor maintenance on their system. Now, there are some tenets that go along with this life cycle that I found very helpful. The first one is provide a solid communications backbone. Treat the Ethernet in your shack as a first-class citizen. And by that, I mean as important as a feed line. In fact, I have a presentation that talks about LAN and the importance of it. You can look for it on YouTube. It was given at last year's QSO Today event. Mike Walker also has a great presentation called Ethernet versus RS-232, and he's giving that talk here at the show. So that is, solid communications backbone is a core tenet of a good station when it's especially with ham radio products by Flex Radio Systems. And like I said before, build the foundations first. Don't boil the ocean when you're building. Build incrementally as you go. Core tenet. Keep the documentation current and organized. So if you change something in your system, take the time after you change it or as you change it to change the documentation set that you have to include the change that you've just completed. And then one of the big ones, especially for our hobby, is manage station grounding and conquer RFI. And I mean, by conquer, I mean, make sure you pay specific attention to it, because everything in your ham shack is an antenna. The desk that's made out of metal, the power cables, the Ethernet cables, everything is an antenna. And especially if you're running with QRO with power, you need to pay attention there. There are some good resources, great ones actually. Grounding and Bonding by Ward Silver and N7HQ is one of the best. And the QST articles by Ron Block that were published in the June, July, and August of 2002 QST. Those are really great places for the start. Ron's articles focuses specifically on lightning protection. Now, we've been asked many times for what has failed. What do we see? What are the common points of failure? This happens when people are considering the purchase of our products, or just as they age, they would like to know what they can expect. And so what I'd like to do is kind of go over a ranked set of those. These are not all of them, but it'll give you some idea of the buckets of problems that we commonly occur. The number one of all problems that we see have to deal with the communications that are available to the product. It's not that the product has failed in any way. It's that the communications layers that are used to interface other pieces of gear or software have been either misconfigured or have failed in some way. And local area networks are right at the top of it, and then out to the internet is probably the next one. But that's why building the foundation and treating your network as a first-class citizen is so important. The interconnects that are not communications related, like some of the signaling interconnects, audio interconnects, the push-to-talk interconnects, those kinds of things are common points of failures. And then software, not necessarily the software that we ship, not that our software is bug-free by any means, but software changes and operating systems underneath it change and create problems as the system change. So that's a common point of failure. Another common point of failure is just plain old operator error. And it could be because something has changed. They may not know about it, but more often than not, it's that they didn't understand how something worked, or they made an assumption or took some advice from someone that didn't know. Accessories is always a point of failure, although down the list a bit. Adding things to the system, and growing the system. As soon as you expand the system, you increase the area which problems can occur, and accessories can create problems sometimes. Feed lines and antennas. This is, the nature of our hobby is that we're actually plugged into nature. We interface with the world, so to speak. So, because the world can generate things like lightning storms and weather and water and wind and other things that can affect things that you have outside. The fact that we, for the most part, interface with outside things, we have that to contend with, and it's a common point of failure. Next on the list was power supplies. Power supplies are generally fine, especially today. The switching variety offer, good high power, low friction interfaces to them. They don't weigh very much, and they're small in size, but they can also generate hash and noise if you don't get the right ones, or they can fail and cause problems for you in other parts of your shack. And then finally, on to the individual components. Components on boards. That is another area that things break. Especially mechanical connections, things like that. Now, root causes are a different part of this. Now, I ranked the failure causes up there, but they're the failure points of failure. Now, here are like the root causes as we investigate what the actual problem is. Number one at the top of the list is faulty information, or information that's based on assumption. And there's a number of different buckets, but the three biggest ones are TDLR, too long, didn't read the documentation. One of my favorites is insert name here, told me so. So while, Elmer's and a lot of people that are out on the community are great, I think you should always operate within a trust but verify. So if someone tells you that something is so, it would be nice to be able to go read it someplace, check the documentation. Not that I'm saying that they're wrong. It's just that we've seen where a faulty information can get propagated and can cause problems for a group of people. And then the other one is just no documentation. I mean, there's, face it, part of our hobby is experimentation, and sometimes the things we connect to our stations, there's really no documentation for. So we're kind of on our own to that, and that's a common point, a root cause for failure. Being overly complex. One of the points of failures is that you try to boil the ocean. You try to make this big, massive system, and you've got this thing really designed very well, but it ends up being a very complex thing, and maintaining and operating it becomes a problem. A form of operator error is what I call attention deficiencies or deficiencies, and that is that if you didn't read the directions, that's one sort of aspect of it, but just not paying attention, switching bands and forgetting to switch an antenna, forgetting to remember that your amplifier is on when you tune, things like that. Attention deficiencies. We operate equipment, many of us high powered equipment, that can not be very forgiving if you don't pay attention. So my advice to you is don't operate a radio the same way you would operate a car, right? You wouldn't get into a car if you're snookered, for example, or you're sick and you're not feeling well. Don't operate your radio either. Issues with the environment. I mean, that's a big one for us, especially during lightning season. Software updates, OS updates in particular, third-party updates. Things change. Software changes things, and sometimes the interfaces that you've relied on, or the configurations that you've relied on, aren't there, or they've changed somewhat, and you need to change the way that things are working in your system. Again, documentation is a very important aspect of this. So if you make changes to the configuration in your system, be sure to document what those changes are. Next up is thermal damage. Again, we operate high-powered gear, and when you operate high-powered gear, especially a linear amplifier, a solid-state linear amplifier, there can be thermal damage. You can heat things up to the point where they fail, or they fail the next time you turn them on. Many of the pieces of hardware that we have, all of the pieces of hardware that we have that have a power amplifier in them, they have thermal management programs in them, or functions in them to help protect against this. But you can still heat up a transistor until the transistor fails, or heat up a resistor until the resistor fails, or heat up a cable until a connector fails. Thermal damage is a common root cause failure point. Mechanical shock. And I kind of lump shipping damage into this. So if you ship your equipment across country off to a de-expedition, I mean, this is why de-expeditions carry extra gear, is because, moving these pieces of equipment around, they're really not designed to be, put in the back of a pickup truck and bounced around a country road. So mechanical shock is a common root cause failure. And then at the very bottom of the list is either a manufacturing or a design flaw of some kind. At Flex Radio, we do our very best to make sure that we design and we manufacture the products as they're designed. Occasionally, parts go bad, or there's some manufacturing flaw. We're not, it doesn't happen very often, which is why it's towards the bottom of the list, but it can happen, and it is a root cause that you may deal with at some point in your amateur radio career. And then very bottom of the list is an actual failed component. This is a rare occurrence these days, mainly because of the quality control processes that are in place, but it still can occur. There can be a component that fails because of, it's just bad. It just had a bad failed component. Okay, now let's talk about some of the common points on a Flex 6000, 6600, 6400 transceiver that you can interface to. This is now we're kind of into some of the meat of the Flex Radio specific content here. So this is the rear panel of a 6600. 6400 looks similar, except that it doesn't have a second set of transverter ports. Everything else is pretty much the same. An M model would look identical, except that it would have an HDMI connector here. I don't cover that because they're kind of single purpose things. But at the very top of the list is the power input. It is an input. It is designed for use with 45 amp power pole connectors. Now, when the size of a power pole that a 45 amp contact will slip into is the same size that a 15 amp and the same size that a 30 amp contact will slip into. So you can't just look at the plastic of the connector and understand that it is 45 amp. You need to look at the barrel of the actual connector. The metal tabs are all the same. It's the barrel. It's where the wire crimps. That is really the thing that tells you that it's 45 amp. So we ship currently with 5 foot long 10 gauge wire 45 amp power pole connectors. If you're at up to 10 feet and to 20 feet, you're going to need 10 gauge wire. If you go beyond 20 feet, you're going to need 8 gauge. So look at the difference. This is so important because even an ohm of resistance at the power levels that we're talking about here, power and voltage, can generate 20 watts of heat. and that heat has to be dissipated, and it's usually a connector that does it, and the plastic may soften and be deformed. The ground plane connection on the 6400 is a simple binding post. Again, we recommend The Excellent Works by Ward Silver and Ron Block. Get accustomed to those. Ground your system as they describe, and that will help a ton of things. I see a comment that says, no, the metal changes among 15, 30, and 48 amp power poles. That may be true. What I read about the spec said that you may purchase the metal may change in what you purchase, but the physical size of it, it looks identical. You're not able to tell simply by looking at it whether it's 15, 30, or 45 amp. That was my point. But thank you for that correction. The next is the power speaker. This is an output. It's an 1/8 inch or 3.5 millimeter stereo tip ring sleeve connector. It uses the tip is the left channel, the ring is the right. The output of this is consumer line level, minus 10 dBV, and it is adjustable by the volume control on the interface. So it's not a constant line level output. It is adjustable. It's intended for use by a powered speaker. Do not plug this into a low impedance speaker and expect to hear anything you're not. The key is also an 1/8 inch stereo. It's wired for the dot to be the tip. The DIT would be the dash would be the ring, and the dot is the tip. The shield is common, not necessarily ground. It's common to those things. You can change this interface in the software so that you can plug a straight key in if you wish. And in that case, the tip is the contact that will do that. But you do need to change that in the software. Phones. This is also an 1/8 inch, 3.5 millimeter output. Tip left, right ring. Shield is ground on the ground plane. It will develop 25 milliwatts at 16 ohms or 12.5 milliwatts at 32 ohms following Ohm's law. So you can expect to hear this if you were to put it on a low impedance speaker, but it's not very loud. It is intended for phones, not to drive an external speaker that's unamplified. I don't recommend plugging this into a set of speakers that does have an amplifier in it. You're not going to have very good results. Now, the microphone input here is available on both the 66 and the 6400. It's also an 1/8 inch, 3.5 millimeter. It's designed to host a dynamic or electret microphone. It will supply bias for electret microphones, but it is about 3.3 volts through a 2.1 K source impedance, right? So you may get about 3 volt bias basically out of that. It is not designed for microphones that require higher voltage bias. So a 5 volt microphone may not work. A 48 volt phantom power microphone will not work. So be aware of what the bias power requirements are for your microphone, and you should be fine. The balanced input is an interesting one. It's only available on the 6600. It's a 1/4 inch or 6.3 millimeter stereo tip ring shield connector, following the same pattern. The tip is the plus and the ring is the minus. It is designed for consumer line level input, but it will also work with a microphone. and you can switch in the plus 20 dB gain onto this input if you so wish. If you set the selector to line, on the interface, the GUI interface, you have BAL for balanced or line. If you select it for line, it will not work with the plus 20 dB preamp, and it is designed for a consumer line level of minus 10 dBV. So it will accept both a balanced line level input, or if you select BAL on the GUI interface, it will work with a microphone. The PTT, TX request, and remote on are inputs. They're RCA jacks. This is designed for you to switch, which means we supply a pull-up resistor, about 3.3 volts, and you ground them to indicate the signal. So you switch it. You do not put a voltage into this connector. It's not designed for that. It does have a ESD protection. All of these inputs and outputs have ESD protection on them. So you don't need to do that, but you do need to supply some RFI protection, especially if you're in an environment that is susceptible to RFI. We do this. We do bypassing, and we have ferrite beads on the inputs of these things, but that is sometimes not everything that you need. The TX1, TX2, TX3 are outputs. These are designed for the radio to switch, and they will switch up to 40 volts DC at about 140 milliamps. They're designed primarily to either close some relay or to signal some other digital input, like a PTT on a transverter or another amplifier. Do not connect these to older style transceivers that sometimes have a high voltage level, high voltage PTT lines. You'll need some sort of a PTT interface. The ALC is also an input. It's RCA, negative going DC. So it will provide a transceiver will provide from 0 to minus 4 volts DC as ALC if your amplifier requires it. Most of the newer amplifiers don't require it, but there are some people that do. The shell is grounded to the ground plane in this case. 10 megahertz in is available on both the 66 and the 6400s, and you do not need to have the optional GPS DO option installed for this. This will take an external sine or square clock input. The minimum is 1 volt peak to peak. The maximum is 3.3 volts peak to peak, basically plus 4 dBm or plus 15 dBm. And if the radio detects a 10 megahertz, a clock signal there, it will synchronize its internal 10 megahertz reference to that reference clock on boot. If you remove this signal during operation, the transceiver will use an internal 10 megahertz oscillator, and it will ignore any reattempts to add 10 megahertz back in by plugging something into the back of the radio. It has to be during boot that this is detected. The GPS antenna and the 10 megahertz out are outputs, female SMA connectors that are only available if you purchase the GPS DO option. The GPS antenna will work with most DC biased antennas. It will put out between 3.3 and 5 volts DC. I haven't seen an antenna that it hasn't worked with. Some of the marine stuff is an excellent antenna source for these. The output is a buffered 10 megahertz at 3.3 volts peak to peak. It is suitable to chain to test equipment that you may have, or other equipment or transverters that can be steered with, have oscillators that can be disciplined with a 10 megahertz input. It will work as an input to the back of another flex radio. Ethernet, of course, this is auto sensing 100 megabits or 1 gigabit per second. 10 megabits will not work. If you have a 10 megabit connector, it does not work. You do not need to worry about polarity on this plug. It has auto polarity detection, so you don't need a crossover Ethernet cable if you want to connect it directly to a PC, for example. We have two USB 2.0 Type A connectors. They are typically used for band data or transverter switching USB devices. They're not intended to charge your cell phone and should not be used for that. So please don't use them for power. They're unqualified. There are only a handful of qualified devices. Those are the only devices that you should plug in to this. You can't expect to plug a keyboard in, for example, and have it work. All right, so here's some best practices with the 6600, 6400 rear panel. Always use an equal to or greater than 30 amp DC supply. Don't use a 20 amp. The way that we calibrate these radios for full output, 100 watts, is when there's 13.8 volts available at the back of the radio, not at the power supply, at the back of the radio, and the PA temperature has been pre-warmed up to 40 degrees C. Those are the two things that we use to calibrate, so that if you slide the 0 to 100% power scale to 100%, that we calibrate it to get about 100 watts. Keep in mind that if PAs are cold, that you can get more than 100 watts out of one of these radios, not usually more than 10% or so. And as they heat up, the efficiency will go down, and you can see less than 100 watts. It's not, you're not going to get dead on 100 watts if you dial up 100 on this. There are factors that are involved on that. Get in the habit of knowing what the voltage is as it's presented to the radio. You can either measure it directly using a voltometer if you wish, or there are third-party utilities. FR Stacks is one that will display that information, make it available to you on your PC. It is exceptionally handy for that. If you're at 10 foot or greater, if you're greater than 10 feet, use 8 gauge wire, again with a 45 amp power pole connector. Now, the 45 amp power pole connectors are designed for 10 gauge wire, so there's a bit of a conundrum there. So you may need to have some shorter pigtail to make that transition, but the majority of that run needs to be accounted for in bigger gauge wire. Make sure you ground the ground plane of the radio, the chassis of the radio. Make sure that you follow the proper grounding techniques if you're going to use one. There's nothing worse than running a long ground wire from someplace to someplace else and then find out that it is really acting as a counterpoise to your antenna, and you end up with RFI all over the place. When you're connecting things, label both ends of your connection. There are some really great tools out there that will provide really nifty labels that don't rub off. I recommend investing in one of those. If you don't want to do that, there are also tape-on kind of affairs that you can write on to do that. But make sure you label the connections. The first time you take one of these things out for service and you disconnect everything and you go connect it back, you'll know what I mean. Employ ferrites on all active lines. A mix 31 ferrite, you can size it appropriately for the cable that you're using, but do everything: the DC, audio, mic, USB, and Ethernet. Keep RFI away from your from your system. This is a computer. The Flex 6000, 6400 has one computer in it. The 6400M and the 6600M has two computers in it. They are computing devices, and as such, they can be disrupted by RFI. So conquering RFI is a really important thing, and you should spend time on it. Regularly test your Ethernet and throughput for errors, especially when you're transmitting. There are a number of ways that you can measure bandwidth on a network. I always recommend getting one of those utilities and run the test when you're transmitting a carrier, on your favorite bands, and make sure you try different bands because RFI can change. If you see disruptions to your Ethernet, look for ways to fix them. Ferrites are one. There are also third-party Ethernet devices that will do some isolation for you. There's other ways to do this, but test during TX. On all of your audio, especially the powered speaker line, use an audio isolation transformer. They're like $10 at Amazon. And they are real handy and nifty to use. They're also 1/8 inch or 3.5 millimeter connectors. They have a little jumper that you can put a ferrite on easily, but this decouples the audio from whatever device you're putting to, and it really cleans up the audio. You don't get digital artifacts that you can hear on it, and it is something that you should just be standard. If you use the powered speaker output on this thing, connect an audio isolation transformer. Use a remote controlled relay for remote on. So if you mount this in a rack, or if you have the radio remotely, turning the amp or the transceiver on and off, unless you get in your car or you moved where your rack is, it can be really inconvenient, or in some cases even impossible for you to do. So having the ability to cut power to the radio by turning off the power supply if you're remote is one way to help do that. But use a remote control relay on remote on. Don't just put a shorting plug in there, especially on M model radios. It's the best way. It's also a way that you can power cycle the radio. It's like pushing the button on the front panel yourself. Have a 50 ohm dummy load related for whatever your max power is at your station. Being able to test into a dummy load is a very key thing especially when there are transmission problems. One of the very first things our help desk technicians will ask you to do is to transmit into a 50 ohm dummy load and provide metrics back to them, whatever they're asking for. You really should have it. Invest in one, make one. There's lots of ways. You don't need to get one that'll support key down for 7 days. You don't need anything that big. But if you have a 1500 watt amplifier, make sure you have a dummy load that you can at least test briefly that output. And then, for goodness sakes, spend the extra money for lightning arresters. Put them in between your antenna and the feed line into your shack. It will save you dollars. Even if you don't get a direct hit, the ability for the planet to induce static charge on a wire antenna is well known, and it has been the demise of way too many radios that we've seen come into Flex for repair. And when we get a lightning radio, we cannot repair it. We basically invite the customer to purchase a new radio, and we will happily provide a letter to their insurer that it's been damaged by some sort of ESD event. It's not a repairable. Even if we fix it, we were able to fix it. The chances of other components being damaged that we did not detect is extremely high, and we've just seen way too many people send their units back to us, after a brief run, after we've repaired them. So our policy is not to fix lightning hit radios. Buy insurance. I'm not making a plug for ARRL insurance, but I have it. It's inexpensive. For $300 a year, I have my entire station covered. And it may be like wrapping $300 and wrapping it around a firecracker to some. But if I ever get lightning here in West Texas, we get lightning, we get a windstorm, anything, I'm covered, and I don't need to worry about it. So those are all best practices. Here is a look at the accessory connector. This is a high density DB15. I'm not going to go through each one of these these things because I've covered most of them. But keep in mind that when we say things like the I2C bus is used currently by factory and service, don't ground the I2C bus, please. Make sure you use the ground pins that are designated here on the connector. They're designed to work handily with the signals that are there. And always recommend putting some sort of strain relief on the cable that you have. The other connectors on the radio are really the RF, the business end of things. I won't go into it. What antenna 1 and 2 are, you should really know they're really the primary RF outputs. On the 6400, you have an RX in and a transverter port. You don't have an A or B. They work, the RX inputs are a direct feed into the input of the preselector that's connected to a spectral capture unit. It is intended for use as a receive port. You do not want to transmit from a 100-watt transmitter or a 10-watt or even a 1-watt into this port. It does not. It will break it, and it will cost you $1 to get it fixed. So use it for a receiver. The transverter outputs will generate between minus 10 dBm and plus 10 dBm, basically 0.1 milliwatt and 10 milliwatts output. They're designed to work with either external amplifier or a transverter. They're also very handy. By the way, the Flex works as a pretty good spectrum analyzer. So if you have the ability to attenuate the output of another transmitter that you want to test and get it into the that range, 100 watts will take about 40 dB of attenuation before you'd want to plug it into it. But we use all the RX inputs all the time as kind of a cheap spectrum analyzer. So here's a couple of thoughts about RXA and RXB. They are receive only, but they can be paired with either an antenna 1 or antenna 2 for transmitting. So if you have a receive only antenna and you have you want to transmit on 2 different antennas on antenna 1, antenna 2, it's real easy to do in the interface. The transverter ports can be used for transverter operation or as an additional receive antenna port, like we talked about. For high-speed CW, you can separate the RX and TX antennas that will help remove switching delays. So that will make people who are like QSK anxious, happier. But the TX antenna must be connected to antenna 1, and the RX will have to be to one of the RX ports in order for that to occur. Okay. We're getting to about 15 minutes here left in the presentation, so I want to just kind of zoom through these things. One of the benefits of purchasing a Flex Radio product is that we have done a lot of work to make sure that they snap together really easily, and it's super easy. So quite literally, in less than a minute, I could connect a 6600, a PGXL, and a TGXL. As long as I have all the cables, everything, connect them all to power, connect the Ethernet, connect the coax, turn the thing on, do the basic configuration with the utilities, and operate. And I can do that in less than a minute. So all of the integration has been taken care of by our software and hardware engineers. You don't need to worry about any of the minute details. You can basically just hook it up and play. So here's an example switch. Now note that diagram on the right. That's using that template library that I mentioned in draw.io. So you can build very, very professional looking diagrams to the backs and fronts of the products that we sell. So this is how you would add a AntennaGenius to a Flex 6600 in this case. It's a single 50-ohm jumper, and you have up to 3 antennas. This is a 1x3 version. Note that I have installed ferrites on the Ethernet and the power cable here. And if I had a power line shown for the 6600, there would be one there too. This is an integration for an SO2R station using the SO2R version of the AntennaGenius. Really, the only thing that is different here is that you've added another coax jumper, and you have 2 antennas instead of 3 that you can connect to it. Now, if you wanted to put an amplifier in the middle of this, it's just basically inserting that amplifier and making sure the amplifier is plugged into the LAN and is either connected to 220 volts or 120 volts, and you're really on the air. It is clearly quite that simple. There's a little bit of configuration that you need to do to pair the AntennaGenius with the transceiver, and all the rest is handled in software. It's super easy. You don't have to worry about 5-pin DIN or 8-pin DINs, and you don't need an accessory connector. This is basically the easiest way to integrate. If you're using a Nonflex transceiver, it is more difficult, but we accommodate that. But note, you need to have PTT connected. You need to have a way to get the band data to and from each other, and you need power. So it's a little more complex. But we work with RS-232, CI5, binary coded decimal, and pin to band bands of the accessories that we have. And we also will, if we don't have even that, we can sense the frequency and mode on our tuner and amplifier products. All right, so then the next thing is being able to switch antennas. If you have more than, say, 2 antennas, or 3 if you're using a AntennaGenius 1x3, you're going to need additional antenna switches. Now, 403A makes the Genius line of antenna switching products. We have an 8x2 SO2R version that is really handy, works very well with our radios. We have an 8x1 switch that is also integrated well with our products. And we have something called an outboard module, or OM module, that allows you to switch other things. That has relay outputs that can be defined to be triggered based on the band that you have. That's useful if you have more complex switching requirements. And up to 2 OM modules can be added to a single AntennaGenius. In addition, we have AB switching, which is, there's a product called the 8AB, which is basically 8 AB switches in a box, and it's single AB switches. I'll show you a really cool use for the 8AB and the single switches here in the next slide. So the features of the AntennaGenius is that you can easily expand the number of antenna points that you have. There's native TGXL integration, which I'll show you in another slide, that automatically selects the right antenna for the right band and will select the right antenna tuning solution for you. And then you can stack these things in parallel or in series for either more inputs or multi-op situations. So let's look at a couple of those. So here is the basic station. This is my station that I use at my house. Consists of a single Flex 6600, which is the minimum that you need to get started. A 6600 or 6400, you can just buy that one product and you're ready to go. AntennaGenius XL, which is our amplifier. The AntennaGenius XL, which is the tuner and note that I have the SO2R version for this. The AntennaGenius. This stack of equipment is really a complete single op, very competitive. I call it a little pistol station. It gives me access to the antennas. It allows me to set up and compete in SO2R as an SO2 operator in a contest or in any operation mode that I choose, and it's really a blast to operate. I have a separate RX antenna, so if I want to, I can do diversity. It's native SO2R through to through. So there's no special thing that you have to do on our software. It understands if you want to be in an SO2R mode. It's super clean, just power, LAN, and coax. That's it. You don't need to do anything else. You get full legal limit, 100% over the LAN control and operation. You can have this in another state if you want. Fully remotable. You can do a single pane of glass control on this thing, and it gives you RX diversity. And in my case, I recommend having a 3 kilowatt dummy load. So, and it's got a ton of port isolation on the AntennaGenius. You get 70 dB port isolation. I see a question here. Does the PGXL and TGXL pass signals to the 6600 on both ports at the same time? If you're using the SO2R version, the answer is yes. You could be transmitting out one port and receiving on another. There are 3 open antenna ports in this particular case that I could add different things to. All right, so let's look at briefly the AntennaGenius integration and automation, and I'll stay later for more questions. So we'll have plenty of time for Q&A. Don't worry about that. So AntennaGenius is easy to integrate with the TunerGenius. You simply just supply an IP address. That's actually going to get easier in a future version of the software. It gives you full LAN control. It takes your AntennaGenius configuration and extends it directly over to the TunerGenius. So if you have a tri-band 40 meter, 80 meter, 160 and a dummy load, and you've described these bands for them, you will see corresponding band and configuration slots over here in the TunerGenius, allowing you to set minimal SWR if you want, or bypass them completely if they're resonant or like a dummy load. So you don't need the TunerGenius. It really makes, this is like first class automation. It is really a point and click affair for you. And it also unlocks additional solution memories in the TGXL, so you can have more solutions per band than you would if you didn't have the AntennaGenius. Custom SWR targets, as I talked about, and you can customize a frequency range or fully bypass the band if it's for like a dummy load. Okay, so the expansion options, and this is where it gets really cool, right? So let's say that I needed more antennas, and how do I add more antennas to something like that? Well, you add 2 AB switches and another AntennaGenius, and there you go. You got 16 antenna inputs. You can go up to 32 antenna inputs if you really wanted to have that, and they can all be defined and work together. Now, let's say you wanted to add a whole nother station operation. You wanted to build a contest station. So here is a basic 2 operator contest station, each with their own stack of equipment, but you can do SO2R at each one of these and use the same set of antennas that you have and share them between the 2 stations. You notice that I'm using an 8AB. that allows me to switch which AntennaGenius is getting the antenna, and you can set it up so you can do automatic lockouts if so you don't accidentally transmit into someone who's receiving. It's very slick, and again, it's power, pipe, and coax. You're not doing any real heavy duty integration work with this. Okay, what is the reason all this works together? And if you haven't already, I strongly urge you to look at Anna McDermott's API talk. She gave it this morning. I hear it's excellent. I haven't seen it myself, but I know her and I know what she's capable of. I bet you, it's rock star stuff. But the the reason all this can happen is that we have the SmartSDR Open API, and we make it open, right? It is documented at wiki.flexradio.com. You can go there. You can read all about it. It is the exact same API that we use in our SDR client. We don't use anything more than this. It's published in full. There's no secret backdoor stuff. It is all up there. And it allows you to, it's used by all clients. In fact, we ship a library, a C# library, to make it really easy to use that API with every release of our software. And I'm showing you here a basic transceiver that I built using that library. It took about 250 lines of code, and I have a complete transceiver using that API. I mean, it's not real pretty, but it's really easy to work with. And here's an example of what the API looks like. It is human readable. This is a little app that I have that I'll be happy to give you if people are interested, that allows you to experiment with it. Everything is readable. It locates the radios via a network discovery protocol that is standard. It's not a flex standard. It's VITA 49, which is in use by the industry. It issues commands to the radios. It will query the radio for status, and it also receives streaming status information from the radio. So it is the heart of why our products work so well together. We share this with our partners like for Oscar 3 Alpha. We share this with people that build really great products. Our Macintosh client is built using this API by a really great guy. We have lots of tools. I use FR Stacks, which is a very popular add-on third-party tool that uses the API. So it's in use by a lot of folks. We also have media streams that are generated by the radio, right? So these are all provided over standard VITA 49 UDP packets. They're pre-processed. So when someone looks at our interface and they see a pan adapter that has a waterfall and it has a nice looking spectrum display, each of those streams have already been crunched. All the math is done on them. All you need to do is take those streams, and if you're a coder, you'll understand what I mean by this, and just display them. You don't need to run them through any fast Fourier transforms. It's all done for you. We have they're pre-processed. We have the RX passband is in PCM audio. That's streamed over. You can select that. And we also will give you raw IQ data streams that will cover the full bandwidth of that's available on that radio, like 7 megacycles on a 6400 or 14 megacycles. You can look at the entire, whatever this spectral capture unit is seeing, you can look at that whole thing and roll your own stuff with it. Very cool. We have a meter protocol that you can attach to. Here's an example of a third-party tool that is looking at the PA temperature inside of one of the radios. You can graph it. You can display it on a peak hold meter. You can do all sorts of things with that. That's simply available by subscribing to it, already crunched. And here's an example of that C# library. It's already done for you. It's used by many of the clients and utilities, including our very own product, and we update it every time we update the software. And then we're also working with the GNU Radio folks, and we have something called the Waveform API, where you can roll your complete own mode if you wanted to do some experimental new FT97 or whatever. You can use that, and you get access to the raw streams as they come out of the radio, and your mode will actually show up as a mode on the user interface in the radio. And again, be sure to see Anna McDermott's talk. She is a super brainy person, and I'm sure you will enjoy every bit of it. Now, another person you need to get in touch with, actually two people, three, is Dave DeCoons, WO2X, and Mike Walker. They've had a QST article in September of 2021 about Node-RED. This is like next level automation. This is where you can do the whole single pane of glass, control your rotor, control your world, your lights, whatever you want, you can do on this thing. And then be sure to look at Kyle Krieg's AA0Z introductory talk on Node-RED. It uses this API and gives you this really slick ability to integrate. So anyway, that's it. I used a little more than an hour. Lots to talk about. This was a information-packed presentation, and I do thank you for attending. I'll hang around here and take your questions at the end. These are resources for you. Be sure to use them. The wiki, the community, the help desk. All you need to do is remember those things. They're all at flexradio.com. And then, of course, I'm available to you, Dan at flexradio.com, if you'd like comment, or you need need me to find someone to talk to at Flex. You have a unique problem that our help desk can't solve for you. So anyway, thank you very much, and I'll toss it back to our venerable host, and we'll start taking questions.
All right. Thank you very much, Dan. And again, that was a great presentation. Really enjoyed that. And I believe everybody in the chat did as well. We have a couple of questions just coming in now. I know you answered a few during the presentation. Here's kind of a loaded question. If you're interested in taking a stab at it, D Middleman asks, if I'm just getting started in HF, what is the minimum that I need? A transceiver, DC power supply, and antenna? Do I need a AntennaGenius and TunerGenius as well? What's your thoughts, Dan?
Well, if you're just getting started, my recommendation is not to go out and boil the ocean, right? Get a transceiver, get a basic antenna up, start experimenting with the hobby, understand what you want. You can always add those things later. I'll be happy to take your money if you really want to buy that. But start with a good transceiver, and our 6400 is a great entry-level transceiver. You're not going to be able to do SO2R with that, but that may be something that's drawing you into the hobby. So if you're interested in that kind of operating, then get a 6600. And so you can start with the basic transceiver and go from there. I will say though that we have a great deal on our PGXLs, our Power Geniuses, at the show. There's a $700 show special, and we have a stackable $300 off coupon available as well. So you can get a full 1K off of the Power Genius. It would be a really good time to buy them right now.
Very good. All right. Let's see. We have another question here from John, and he requested a link to our particular audio isolation transformer. I know there's a ton on Amazon, but do you have any favorites?
The one that costs like $9. I mean, there's probably like 3 of them, right? There's really not a lot. I'll be happy to share a link with you in private in the chat. Hold on, can I get to chat?
I
don't
think
think
that's
so.
only for the participants asking questions
Okay.
here. So,
Yeah, just search for audio isolation transformers that take 3.5 millimeter plug, and you're good. The Amazon, what's the one favorite of the Amazon Basics? Maybe that would be the one to choose.
mhm.
Yeah.
All right. Let's see a few other questions coming in here. Somebody else asked about John Caulfield also asked a preference on a particular connector labeling tool as well.
Oh yeah, that's a really loaded question. Yeah. The I am really a labeling geek, and so I have one that costs well, it costs more than 500, but less than 1,000, and we'll do shrink wrap labels on it, and takes like spool fed, and so you probably don't need something like that. But I strongly recommend the ones that come off of a printed machine. There are a number of companies that make them. Get the model that makes the most sense for you. Uh, if you can't afford one of those, a pen and labels that have protective, clear tape that go along them is another good alternative. But um, if you want to send me an email, Dan at flexradio.com, I will send you what I have, and then um, you can make a decision yourself too.
All right. We had another question from Russ Ravilla, KR6W, and he mentioned that there had been a few bugs in SmartSDR for years to prevent FreeDV from properly working. And he says that the previous D-Star option is another example of features that don't work due to bugs. Is Flex ever going to fix these bugs? And then the message drops off.
Okay.
So,
So the issue is less bugs than available bandwidth, processing power in the radios themselves. So yes, we are working on that. Anna, in particular, has an interest in both of those waveforms. I would reach out to her. She's worked on um, on both of them and has them working sort of. But the primary issue is the the amount of horsepower available to process those on the radio. Now you can do it externally using an external processor, but if you want to use them as written and have them run on the radio themselves, you're going to need to wait for a couple of releases, because we're working on improving performance. I can't get into details on when,
mhm.
but the next release that we have will not be at the one after that will, but we'll make a significant change that should increase performance and would impact those two waveforms.
Very good. And I also, let's see, I don't see any questions right now in the chat. Feel free to keep asking them because I know Dan's willing to stick around a few more minutes, I believe. I had a personal question that I came up with during the presentation that I was curious on. I was wondering if you had any experience with RFI between the computer and the Flex and the radio portion, and if so, what steps you've taken to reduce that from being a thing with either from the computer to the radio or the radio to the computer.
Okay, so first of all, is finding out really where. Um, and the yes, so the answer is yes. I get it. And um, the worst kind is when you click transmit and then suddenly the interface stops and you realize that the it's locked in transmit, and you've got you have to wait for our watchdog to time out and kill things, or pull the plug some other way. But I've found three major offenders: USB devices, like headsets, mice, things like Stream Deck, right?
Mhm.
Which is works. You got to put mix 31 ferrites on all of those things. Uh, the Ethernet cable has been less of an issue, although I have seen some. Ethernet is interesting because is RFI from just certain bands. Like for some reason in my shack, 12 meters is like just raises hell with my Ethernet. I don't know why, but I put ferrite on everything, and that usually takes care of it. And then the power cables. That's easy. It's really easy to forget those. But any length of wire that you have is like an antenna, and if you are transmitting at 1,000 watts, and and your coax ground is participating in that in some counterpoise way, you're going to have RF in the shack, and you just got to mitigate it. But yes, everything.
Yep. All right. Just a few other. Let's see here. Just see a few other comments coming in. A few people saying thanks. Bill said excellent presentation, Dan, and also Daniel AA4HV said I want to say thanks to Dan for another of his great, informative, entertaining presentations. And I will second that as well. So with that, don't see any other questions in the chat. If somebody else has any other questions, I think we will shut this down. But Dan, if you want to repeat your contact information, if anybody else has any other questions after the show.
Dan@flexradio.com. Send a request to help desk for one of two things: the template library that I use in draw.io that gives you the nice wire frame drawings of our products, and especially the rear panels, which allows you to document your connections. The other thing is the one pagers that I produced for the pinouts. I will make PDFs of those available. They're really handy reference, but you need to submit a help desk ticket to get it. If you give it to my email address, they get moved to junk, and I'm really poor. But just send a help desk request and go, hey Dan, send me what you want, and I'll be happy to do that.
All right, very good, Dan. Well, again, great presentation. Thanks for doing that today. And
you're welcome. Yeah, thanks for hosting.
Yeah, pretty low friction. Thanks.
Pretty low friction guy. I'm really getting, and I won't ask this. But I do have to. And you don't have to answer me if you don't. But how old are you?
I am 15. So yeah, I've been a ham for a couple of years.
Okay, well, A, you are you've got an extra call at 15, which is awesome. B, you've got a great voice for radio, and and 3, it's been a pleasure working with you. Thank you so much for being a great host.
Thanks, Dan. You too. And I'll admit that I don't have a Flex Radio right now, but after this presentation, I'll definitely hope to go out and buy one. So,
well, we can help you out.
Very good.
Let us know. You bet.
All right. Well, thanks everybody for making it out this afternoon.
73. Thank you.
73.